Hi. So in this video, we're going to look at solving first order differential equations of the type linear, or we could call it variables inseparable. And they will look like a standard form of dy by dx plus f of x times y equals g of x, where they're functions of x. And we are not able to separate the variables, and so we need to do something different in order to solve them. And the way we do that is we calculate the integrating factor, I of x, where the integrating factor is the e to the integral of whatever the function multiplying y is. And what that will do is then if we multiply through by whatever the integrating factor is, it creates a situation which allows us to integrate the left-hand side very, very easily. And I'll explain why that happens in a bit. And then, as with the other differential equations, arrange explicitly in x if possible, and then solve for a particular solution if we need to. Okay, so first thing that we can do when we realize it's dy by dx plus y over x equals e to the power of x is calculate the integrating factor, which is a to the integral of 1 over x dx, which is e to the log x, which is just x. Okay, so now if I multiply through by, we get x dy by dx plus x times y over x, which just becomes y, equals x times e to the x. And now that means when I integrate this, that's not integral sign, I can actually just rewrite this integral as simply x times y, where x is the integrating factor and times by y. If I was to then redifferentiate that, I would get 1 times y plus x times dy by dx, which is actually what we got here. So the reason we're doing the integrating factor is we're creating a situation that allows us to do integration where the left-hand side is simply going to become I of x times y. So in this case, it's just xy. And now I need to integrate the right-hand side, which is a bit more complicated because that's going to involve some integration by parts, but that's straightforward for us, hopefully. We get f equal to x, f dashed equal to 1, g dashed equal to e to the x, so g is equal to e to the x. So the integral of x e to the x will equal x e to the x minus the integral of f dashed e to the x, which is just e to the x. So we get x e to the x minus e to the x. So now we get x times y equals the integral of x e to the x, which we now know is x e to the x minus e to the x plus our constant of integration. Divide through by the x to get it explicitly in x, which gives us e to the x minus e to the x over x plus c over x. Before, when I've multiplied a constant of integration, I've just left it the same, but that's because I've been multiplying or dividing by a numerical constant, whereas I'm multiplying by an algebraic constant, which means we need to actually include it. Okay, and that's actually all we need to do. So it's a method in which we rearrange the function to allow us to integrate it easily. Okay, so do another one. So here we are, we're finding the particular solution this time, so it'll be a bit more difficult, or lengthy rather, of dy by dx plus y over 2 equals e to the power of x. So first thing we can do is find the integrating factor, e to the integral of a half dx equals e to the x over 2. So that means we multiply through by, we get e to the x over 2 times dy by dx plus e to the x over 2 times y over 2 equals e to the x over 2 times e to the x. It's a bit more complicated and maybe it's not as easy to see, but that will integrate to the integrating factor times y equals the integral of e to the x over 2 times e to the x. That's a half x and that's 1x, which means they can simplify to just be 3x over 2, which then will become e to the x over 2 times y equals the integral, which is 3x over 2 times the derivative, times 1 over the derivative of what's inside the brackets, which is 3 over 2, so that becomes 2/3 plus c. Let's arrange explicitly in x, so we get y equals 2e to the 3x over 2 over 3e to the x over 2 plus c over e to the x over 2. 1.5x's minus 1/2x's becomes 1x, so we get e to the x plus c over e to the x over 2. And that, so far, is our general solution. I didn't ask for a general solution, I asked for the particular solution. And we're given the conditions x equals 0 when y equals e. So we get e equals 2/3 e to the power 0 plus c over e to the power 0 over 2. So e will equal 2/3 times e to the power 0, which is just 2/3, plus c over e to the power 0, which is 1, so that's c. So c equals e minus 2/3, which then means that the particular solution at those starting conditions is 2/3 e to the x plus e minus 2/3 over e to the x over 2. And that is our general solution. I'm going to do one more. So hopefully what you can see is that the general solution, find the general solution of x dy by dx minus y equals x squared cos x. It is not in the standard form. So the first thing we need to do is put it in the standard form by dividing through by x. Okay, and now let's find the integrating factor. E to the integral of negative 1 over x dx, because remember the standard form is a plus, so really I should really rewrite that as plus negative 1 over x times y equals x cos x, which gives us e to the negative log x, which is e to the log x to the negative 1, which is just 1 over x. Okay, so now I can multiply through by 1 over x, and I get 1 over x dot dy by dx plus 1 over x dot negative 1 over x times y equals 1 over x times x cos x. Fully can integrate these, knowing that that just becomes the integrating factor times y, which is 1 over x times y. X and x cancel, so we're just integrating cos x. So 1 over xy equals the integral of cos x, which is sine x plus c. So y equals x sine x plus xc. And so that is a general solution when you're not given the standard form. And that is differential equations, first order linear.